Hello students, in this video I am going to discuss a question from the topic permutation and combination. This question also came in RMO exam. The question is, find the number of triples A, B, C where A, B, C are subset of X 1, 2, 3, 4 till N such that A intersection B intersection C is equal to 5, A intersection B is not equal to 5 and B intersection C is also not equal to 5. Now, I am going to give approach how to solve this problem. Now, let us draw Venn diagram here. Given that A intersection B intersection C is 5, so this is 0. A intersection B not equal to 5, this means R2 not equal to 0 because A intersection B not equal to 5. And what about R5? R5 is also not equal to 0 because it is given here. What we have done, we have divided whole space into 7 parts. This is R1, R2, R3, R4, R5, R6, R7. This is 0. This part is none. Nothing is there in this A intersection B intersection C. Now let nx1 represent the number of edge represents the number of edge in which R2 is equal to 0. So if R2 is equal to 0, how many elements are there in set? There are n elements are there. So how many number of edge we can put the element in 6 region because there are 7 region, and if R2 is 0, so nx1 is equal to 6 raised to n. Now what about nx2? nx2 represent the number of edge in which R5 is 0. Now if R5 is 0, again we have 6 region are there because total region is 7, and if we take this 0, so how many region remaining? 6 region. So nx2 also is 6 raised to n. And what about nx1 intersection x2? What does it mean? nx1 intersection x2 means both R2 and R5 are 0. This is also 0 and this is also 0. This R5. So both R2 and R5 equals 0. If this happens, so what is n of x1 intersection x2? So how many total regions are there? Total we have 7 regions and 2 regions are 0. R2 and R5 are 0. So every element can be put inside 5 edge only. So this is every element we have 5 choices. So total number of choices we have 5 raised to n. Now what about n of x1 union x2? We know that this is equal to n of x1 plus n of x2 minus n of x1 intersection x2, simply by using principle of inclusion and exclusion. So n of x1 union x2, this is how much? This is 6 raised to n plus 6 raised to n minus 5 raised to n. So this is 2 into 6 raised to n minus 5 raised to n. Now what we need finally? Finally we need to find R2 not equal to 0 and R5 not equal to 0. Now we need to find n of x1 union x2 complement of this. So this is what? Total number of ways of putting this one in how many space? 7 space, 7 raised to n. So total number of ways of putting the all element is 7 raised to n only. Because for 1 we have 7 choices, for 2 also we have 7 choices, for 3 also we have 7 choices. Every element we have 7 choices. So it is 7 raised to n. So n of x1 intersection x2 is nothing but this 7 raised to n minus 2 into 6 raised to n minus 5 raised to n. So this is what finally what we get. This is 7 raised to n minus 2 into 6 raised to n plus 5 raised to n. So this is the required result. So hope you understand the solution and enjoy the video. Thank you and see you in next video.